look at collecting data from only some people instead of everyone. Now, it turns out that collecting data from only a few people, which is called a sample, instead of from the entire population, can be done wrong in very, very, very many different ways. So there's lots and lots of ways to do sampling wrong. There are very few ways to do it right, and we'll talk a little bit about some common ways of doing it wrong and some ways of doing it right. First one is a simple random sample. Sometimes we call that an SRS. And the big idea here is that it's random. Everyone has an equal chance of being selected. So imagine you had a bunch of names in a hat and you picked one out at a time, and everyone had an equal chance of being selected. That would be a simple random sample. Convenience sample. This is a bad type, and you can see that convenient usually doesn't mean you're working very hard to do your sample. So convenience sample is a method that involves choosing individuals that are easy to access. So imagine asking your friends or the people that sit at the table with you or the people that are around you. It's basically being a little bit lazy about your method of choosing people to be in your sample. The problem with convenience samples is it does not give all individuals an equal chance to be selected. The ones that hang around you, are closer to you, are easy for you to get to, have a higher chance of being picked than those who you don't really see. Another vocab word is voluntary response. So this is when you ask everyone to participate, but only a small percentage actually respond. So we say, consists of people who choose themselves by responding to a broad appeal. If you think about something like American Idol or some TV show that involves texting in or responding online, they'll ask everyone to participate, but only those who really care a lot are going to participate. So it's a little bit biased. It means not all people have an equal chance of responding. Usually those with strong opinions are more likely to respond. First question we have is, if we had the question, who will be the next president? Who will the next president be? If we wanted to know that, let's say we're getting close to an election and we wanted to get a sense of who people would vote for, would it make sense to ask every single person in the country who their opinion, or to do a survey, which this should say sample, so that's a misprint there, a sample of only some people? Now, when we actually vote, when we cast our official ballot, yes, you do want everyone to vote. That's important. There's a lot of reasons why we might want all people to actually participate in the voting of the next president. But if we're just trying to get a sense, an opinion poll to try to get an idea of who the next president would be, we're going to use a sample. The reason is because it costs a ton less money, and people are far more likely to respond to when you're only looking to ask, let's say, 1,000 people. So I just put like 1,000 people here, versus a census. And a census is just asking the entire population. So this is really the same as saying entire population. When we do a census, we would have to ask all 300 million Americans if we asked everyone. But if we did a sample, we could ask, let's say, 1,000 or even fewer and get pretty good results. Let's go through some scenarios and see what happens here. With the convenience sampling, this was that lazy sampling. There's a few different examples that we have that we can look at. Man on the street survey. If you think about any kind of TV shows where they have usually a lot of news programs or comedians will do this, where they'll walk out onto the street and they'll ask people, hey, what do you think about this? What do you think about that? Any type of poll like that usually involves just walking up to whoever you see. And a lot of times the people that they like to ask and show on TV are the ones that have a very strong opinion or have a lot of emotions in their reaction because they're more interesting to the TV audience. The people that don't have very interesting opinions or aren't sure are not the ones they put on TV. So that is not going to give you a very accurate view of the population. that comes into that street surveying is location. Because if you ask about gun control or legalizing marijuana in Berkeley, California, which is a very liberal town, liberal city out in California, compared to a small town in Idaho, which would probably be very conservative, you're going to get totally different answers. The people that you come across on the street in some large cities are very different than the people you come across the street in a small Idaho town. And even if you're in the same geographical area, if you're in the same city, you would probably get totally different answers if you were standing outside a high school with a bunch of kids or a country western bar. So, whenever you are in certain places, both different cities or even different parts of a city, you're going to be biased on what kind of people you run into. So, the bias here is typically on location. And there's a few other things, but we'll mainly focus on location as kind of the number one bias of convenience sampling. Another one that we just mentioned earlier was voluntary response sampling. Usually this comes into play on like any kind of online poll or TV poll. You can see this little poll on CNN.com. It says, is the expense of trying to rescue a dog aboard an abandoned ship near Hawaii justified? Yes or no? So you click your vote, or you choose your option, you click vote, and then it shows you how everyone else voted. In the fine print here, it makes it clear what this vote actually tells you. It says this quick vote is not scientific and reflects the opinions of only those internet users who have chosen to participate. So that means the people that saw this question and was like, who cares? Those people didn't have an equal chance of sharing their opinion. Perhaps the people who don't care were more likely to say no. Whereas the people who see this and say, oh, the dog, I saw the story about the dog aboard the ship, it's totally worth it. Yes, yes, yes. Those people might be far more likely to respond yes. So that's why any kind of online polling or TV polling is usually not scientific, because the more opinionated people, those people are more likely to vote. Those with stronger feelings about the topic. Moving on. Another example is Ann Landers summarizing responses of readers. For those of you not familiar with Ann Landers, she used to have a column in most newspapers that people would write in to. 70% of 10,000 parents, so out of 10,000 parents that wrote in, 70% of them said that having kids was not worth it. If they had to do it over again, they wouldn't. But here's the problem with this survey. Even though there's 10,000 letters, which is a lot, that's a big sample size, it's very, very, very biased, because the people who wrote in to respond to this particular article that she wrote were probably the ones that felt strongly that having kids was not worth it. And later, they did a truly random sample, showed that 91% of parents would have kids again. So even though this survey with 10,000 people said that 70% of parents say that having kids was not worth it, it turns out that most parents that enjoy their kids were probably spending the time, instead of writing into this newspaper column, hanging out with their kids or something like that. The idea is that when you collect information where people voluntarily choose to respond or not respond, you end up getting data that can be very biased no matter how many people are in your survey. Another example is to assess the opinions of students at The Ohio State University regarding campus safety. A reporter interviews 15 students he meets walking on campus late at night who are willing to give their opinions. The population, always remember, the population is who you're trying to study. So the goal is to learn about students at Ohio State. So that will be our population. But what is the sample? Who do you actually get the data from? So the population is who you want it from. The sample is who you get it from. In this case, it was 15 students he meets walking on the campus late at night. So that would be C, the 15 students interviewed. All students walking on campus at night, not all students walking around at night got interviewed. Only 15 of them did. All students at universities with safety issues? No, they only were at Ohio State. They were not at all universities. And all students approached by the reporter. There are probably some people that the reporter walked up to and asked for their opinions, but only those who were willing to give their opinions actually became part of the sample. So the important part to see here is that the population is who you want to learn about. So you want to know about. And the sample is who you actually collect information from. So that's who you want. Sample, who you get. The idea of a good sample, a representative sample, is one that gets people that have, so that the group from the sample have the same overall opinions as the entire population. That would be a good sample. And now let's talk about some non-biased techniques that give everyone an equal chance of being selected. Let's figure out which of these are non-biased. Drawing names from a hat. Well, that gives everyone an equal chance. So if you put everyone's name in a hat and draw names, then everyone has an equal chance, assuming that you obviously do it in a fair way. You don't give some people a very large piece of paper in the hat or something like that. You make everything equal and put their names together in a hat. Next one, it says, wait for the first 5 people who randomly walk in. Now, if you're waiting for the first 5 people, you have to be very careful with this word random. If you're someone like me, you never randomly walk in early to anything. You're usually one of the last people to walk in. Some people are always early, and usually the people who are early are a little bit different than the people who are typically late. So knowing that not all people are the same, you might have people with totally different opinions that walk in early and totally different opinions that walk in late. So for B, I would say no, that is not a non-bias. There is some bias there. C, assign everyone a number, then generate random numbers. This one's a little bit interesting. Imagine that you had a list of names, and for each one, you gave them a number. Let's say the first person is number 1, 2, 3, 4, 5. And then you had a random number generator. Let's say it was a computer, or I guess if you had a small enough number of people, you could use dice. Something like that. Something that will generate a random number. And once you have that random number, you use that to figure out, okay, I randomly generated a 3. That means, okay, I picked Bob. I randomly generated a 5. That means I picked Mary. That would be a non-biased technique, because in that kind of situation, if you give everyone a number and then generate random numbers, everyone has an equal chance of being picked if you're generating random numbers, and we'll show you how to do that on your calculator. Another one, give everyone an equal chance by asking everyone to participate and accepting those who are interested. Have to be careful with the wording here too. It says give everyone an equal chance to participate and accepting those who are interested. Well, if you're only accepting those who are interested, you're going to be biased, because the people who aren't interested might have a different opinion than the people who actually respond. So by asking everyone and just hoping a few people respond, you're very likely to get bad results. Results that don't represent everyone in the group you're learning about. E, ask every 15th person who comes by during a period of time. This one's kind of interesting. At first glance, it doesn't really seem very fair, or like everyone has an equal chance of being selected. But in most cases, this is generally a good method, because if you think about spacing out over the period of time you have, let's say you have people come in various points along the way, and if you take every so many people, starting at a random spot, and then every 15 or so, you would select somebody that comes by, you're actually going to get a pretty good cross-section of the population. So that's one technique that is generally considered not biased. So this is considered a good technique. And then finally, names are put into buckets for each grade, and then someone's chosen from each. So you have a bucket for 9th graders, 10th graders, 11th graders, and 12th graders. All the 9th graders go into their bucket, 10th, 11th, 12th, and you choose people from each bucket. Is that going to give you a biased group? You do have to be careful with this one. For example, if you had only one 9th grader and 100 10th graders, and 100 11th graders and 100 12th graders, for example, then does everyone have an equal chance of getting picked if you're picking one person from each bucket? No. Because this person would be guaranteed to be picked. They're the only freshman. And then the other people only have a 1 in 100 chance of getting picked. So in that case, it wouldn't work. But if you had equal number of people in each bucket, and you picked the same from each, you picked one person from each, then it would be okay. And in general, there are ways to deal with having uneven sizes. So generally, this is considered a pretty good technique. You do have to be careful with it, but it's generally considered a good technique to. So that's our long look into different sampling techniques, and we will talk more about those in class.